Why can we see through glass? Hello, curious minds, and welcome back to HowWhyTube, your channel for uncovering the science behind the everyday. Take a look at this. Simple, ordinary glass. We look through it countless times a day. Windows, screens, glasses we drink from, the lenses in our spectacles. It's so common, we barely give it a second thought. But have you ever truly wondered, why? Why is it that we can see right through this solid material, while we can't see through, say, a piece of wood or metal? What is the hidden science that makes glass, well, transparent? It might seem like magic, but it's all down to the fascinating ways light interacts with matter at an atomic and molecular level. And today, we're going to unravel that mystery, revealing exactly why glass lets light pass right through, making our world a whole lot brighter and more visible. Get ready to see glass in a whole new light. To understand why glass is transparent, we first need to talk about light itself and what happens when it encounters any material. Light, as you might know, travels in waves and is made up of tiny energy packets called photons. When these photons hit a material, a few things can happen. Absorption. The photons can be absorbed by the atoms or molecules in the material. When this happens, the light energy is converted into another form of energy, usually heat. If a material absorbs most of the visible light, it appears opaque and often dark, like a black t-shirt. Reflection. The photons can bounce off the surface of the material. This is what happens with a mirror, or why you can see your reflection in a calm lake. If most light is reflected, the object appears opaque and shiny. Transmission. This is the key for glass. The photons can pass right through the material. This is what we call transparency. So, what makes glass so special that it chooses option number 3, transmission, for most visible light? The answer lies in its atomic and electronic structure, and how that structure interacts with the energy of light photons. Inside every atom, you have electrons orbiting the nucleus. These electrons don't just orbit anywhere, they occupy specific energy levels or shells, a bit like rungs on a ladder. For an electron to jump to a higher energy level, it needs to absorb a photon with the exact right amount of energy, a specific quantum of energy, corresponding to the gap between its current level and a higher, unoccupied level. Now, here's the crucial part for glass. In the materials that make up typical glass, like silicon dioxide or sand, along with other additives, the electrons are bound quite tightly to their atoms. The energy gaps between their allowed energy levels are relatively large. Photons of visible light, the light our eyes can see with its rainbow of colors, simply do not have enough energy to be absorbed by these electrons and make them jump to a higher energy level. It's like trying to pay for a $10 item with only $1. The transaction just doesn't happen. The visible light photons just don't match the price of the energy jumps available in glass. So, if these visible light photons can't be easily absorbed by the electrons in glass, what happens to them? For the most part, they pass right on through the spaces between the atoms, or they might get briefly absorbed and re-emitted by the overall structure without a significant loss of energy, continuing on their original path. This is what allows us to see through it. Now, compare this to an opaque material, like wood or metal. In these materials, the electrons are arranged differently, or there are many more available energy states for them to jump to that do correspond to the energies of visible light photons. So, when visible light hits wood, many of its photons are absorbed, their energy exciting the electrons. That absorbed light energy is usually converted to heat, and not much light passes through, which is why you can't see through your wooden door. Metals are a special case. They have a sea of free electrons that readily absorb and then re-emit photons, which is why they are shiny and reflective, but still opaque. Another important factor contributing to glass's transparency is its amorphous structure. Unlike many solids, like salt or metals, which have a very regular, repeating crystalline lattice structure, glass is a non-crystalline, amorphous solid. Think of it like a liquid that has been frozen in place before its atoms had a chance to arrange themselves into a neat, ordered pattern. This disordered structure means there are fewer regular planes or boundaries within the material that could scatter light in all directions. In many crystalline materials, light can get scattered at the grain boundaries between tiny crystal structures, making them appear translucent, like frosted glass, or opaque, even if the individual crystals themselves might allow some light through. Glass, being more uniform in its disorder, minimizes this internal scattering for visible light. Now, an interesting point. While glass is transparent to visible light, it's not necessarily transparent to all types of electromagnetic radiation. For example, most common glass absorbs ultraviolet UV light. The photons in UV light have more energy than visible light photons, and this higher energy is sufficient to excite the electrons in glass. This is why you can't get a sunburn sitting behind a standard closed glass window, though some UVA can still pass through certain types of glass. Similarly, glass can also absorb or reflect certain wavelengths of infrared or IR light, which we perceive as heat. This is a key principle behind how greenhouses work. Visible light gets in, warms the interior, but some of the infrared heat radiated by the warmed objects inside is trapped because it can't easily pass back out through the glass. So, there you have it, the hidden science revealed. Glass is transparent to visible light primarily because the electrons in its atoms require a specific, large amount of energy to jump to higher energy levels, and photons of visible light simply don't have enough energy to make that leap. So, they pass through. Its amorphous, non-crystalline structure minimizes internal scattering of light. It's a beautiful interplay of quantum mechanics and material science that allows us to peer through our windows and see the world. Isn't that fascinating? Did you ever realize so much complex physics was behind something as simple as a clear piece of glass? What other everyday phenomena have you always been curious about? Let us know in the comments below. We love hearing your questions and ideas. If you enjoyed uncovering this clear-cut science with us, please give this video a thumbs up. It really helps our channel shine. And if you haven't already, make sure to subscribe to HowWhyTube and ring that notification bell so you don't miss our next exploration into the hows and whys of our amazing world. Thanks for watching HowWhyTube. Until next time, keep looking, keep wondering, and keep asking why.